we've got many designers across regions who are literally designing press tools, mold tools for clients. That's all they have is a computer. Even you look at CAM simulation, we all know about that. Within Visi Progress and the mold, we have a kinematic simulation, so you can actually simulate the die being closed up in a press, for instance.
Welcome to the MTD podcast with me. I'm Rowan, technical reporter and a proud member of the MTD team. Now today I'm here with four Hexagon employees. We have Liam, who's going to be coming on at some point, but firstly we have Phil. How's it going, Phil? Could you introduce yourself, please?
Yeah, not too bad. So I'm Phil Smith. I'm the pre-sales manager of Hexagon, covering all the brands. So that's from EdgeCam to Work and See to Raiden to NC Civil.
And I probably should have specified we're here talking about Hexagon software today. Now I know Hexagon is well known.
Production software. Hexagon
Production software. Thank you very much, Marcus. I'll get you introduced soon. Thank you for jumping in. So Hexagon is all about. It's well known for measurement equipment, but it's not what we're going to be talking about today, is it, Marcus?
Yes, so I'm Marcus Gardner. I'm part of the sales team across the regions. I've been an end user of some of our production software products in the past, has also supported them. Yeah,
and you've been in the industry not very long time. Sorry, I'm not going to be that rude about you.
It's a very long time.
Yeah. No, we've been doing a lot of technical corner videos today. So I remember you were saying, "Don't call me 63" earlier today, and that got you a little bit riled up.
Yeah,
we're okay so far. And then the last but not least, Dave Currer. So Dave, could you please introduce yourself?
Yeah, I'm Dave Currer, application engineer for Hexagon, covering EdgeCam, NC Civil, and designer products.
And you've been kind of using EdgeCam for a very long time now, haven't you?
I've been with EdgeCam for 9 years now, so yeah.
And you remember,
that's a long time.
Yeah, and you remember using. I remember you telling me you using it in 19 something. Sorry, you don't want me to talk about this.
No, I wasn't using it back then, but I'm not that old. But EdgeCam was born in 1983.
1983. As were you, Dave.
Yeah, about then. Yeah, I'll take that.
But I remember you talking to me about the software back in the day when you were first learning a CAM system. In like MS-DOS or Windows 95, and how long you remember it took to calculate a program.
Yeah, that's one of the big changes, I suppose, as software and computers have developed over the years. The calculation time is just incredible now, so quick to calculate. I always remember probably one of the first 3D jobs I programmed, I was told do not press calculate until you go home at night because it takes too long,
And I guess quite people...
Like 5 seconds now, to do that.
A lot of people nowadays could not even imagine that a computer would take, let alone a minute, a whole night to calculate something. You imagine a machine running 30 hours to cut something, fair enough, but a computer could simulate in seconds, right? But they've not always been that quick. And that's why I think there's been a big move towards utilizing software to improve production efficiency, to make design engineers' lives easier, to make operators' lives easier. And that's where Hexagon Production software definitely comes into its own... comes out on its own at the forefront of this of production engineering software, because as I said before, you guys are known for measurement, but that's kind of like the end of the production process. There is a lot of work that goes into firstly designing a part, and then designing the process around making the part, and then the last mile, if you like, is the whole inspection process. So you guys are now moving from inspection all the way back to the absolute start of making a complex part. And you guys, seems like a bit of your bread and butter is mold and die tooling. It's really complex stuff. It's aerospace. This is really the forefront of design engineering. Yep. So Marcus, could you please explain? How does one of these complex designs start life?
Yeah. So just going back to your previous point there, Rowan, Hexagon, especially for the UK and especially what I knew of Hexagon before, it's a metrology company. The acquisition of production software. Companies that have been brought up in the last decade are a big complement to that, because we've suddenly got a metrology company that can actually provide you with an end-to-end solution. So your question on taking apart from...
Yeah, so the start of the design engineering process, which Hexagon has been going. I don't know how long you guys have been in the production software for, but that's when you're starting to explore how you actually changing the way you actually design a part. And I guess a customer might send you a design, or even get a fag packet, or I don't know if you can say that anymore, a cigarette paper sketch.
Or maybe a vape box or something.
A vape box, yeah, exactly.
They exist. Yeah, so we start with one of our CAD systems, and the proprietary one for mold and die we spoke about earlier is Visi software. So we'd be taking native CAD data. Again, we're not worried about who it's coming from because of the way the software works. We're then using an extensive suite of tools for FEA, Visi blanking. When you're coming into the mold, we've got our own proprietary Visi mold for polymorph. We can validate the data very easily and create tooling, create fixtures around it. And that's when we can move within our vast array of CAM systems, Visi, WorkNC, EdgeCam, and others. And that's when we sort of take them into the next step.
Absolutely.
Maybe that's something Phil can touch on in the
It is. So Phil, you're a great advocate for WorkNC. Which, could you just give us a little taste of what WorkNC is, if people haven't heard of it?
Yeah, so WorkNC's started 30 plus years ago. So we've got a good team here in the UK. And a lot of our customers, they tend to use it for mould and die, pattern making, design studios and so on. We use it for components as well, of course. Complex 5-axis is great at. So the engine is 2.5D up to 5-axis. But we have a lot of sort of connection with Visi. So a lot of our customers tend to use Visi for the CAD, and then we pull that in straight into WorkNC to do the milling. So we have a number of customers, Tooling 2000, that they use it for their design, and they use it for their CAM, and then we also have NC Simul, which they use, and then they also have an ARM for scanning.
So they've got a lot of Hexagon software, but also the hardware. And how do those two pieces of hardware and software link together with the scanner, the CAD system, and then back into the CAM again to reproduce a physical part?
So again, if I can butt in on there, Hexagon, obviously, all these brands we have now are under the umbrella of Hexagon Metrology, Hexagon MI. What's happened there is really nice because Hexagon have shared their own kind of technology with the production software. For instance, now you've got two products, Recreate and Visi Reverse, where we can plug aroma arm straight into it and scan data raw, straight into there. That's technology shared, but we've also coming under Hexagon. They've shared the productivity as well as technology between products. We can all, and I suspect Dave will touch on this later on, but we can all seamlessly interlink to NC Simul within each other, like Paul said, between Visi and WorkNC. So, and I guess it's a huge thing.
It's definitely a huge thing. I guess the important point as well is not just the fact that your software integrates really well with the hardware. It's the fact that because you as a company have quite a broad knowledge base, people that have to be flicking through a Keyence, for example, I don't know if I'm allowed to say any competitor, a Keyence catalog, and then maybe a catalog for a software provider. And if they try and go to one vendor and then another vendor for software, and neither of them would really take the responsibility for how to integrate those systems, then Hexagon provide that one-size-fits-all solution for all of, for example, Tooling 2000's problems.
Yeah, and I sort of, I mean, at the end of the day, we've Tooling 2000, they're using all of our brands to an extent. So they're using Visi, they're using WorkNC, NC Simul, using our ARM, of course, but they're also looking at EdgeCam now for their lathe. So it's all the products have a niche market, and they can actually go after that, which is really nice to see. And Tooling 2000, we've actually swapped out a competitor to help them and produce the automation that they need with our solution. So it's great to see that Tooling 2000 and others, people like Petfords, are successful using our solutions and actually getting the money's worth out of our software.
Yeah, and I'm sure Tooling 2000 are pretty happy that you said the name at least 10, 15 times now.
Definitely.
They'll be getting a good
ultimate plug.
Absolutely. Yeah. They're very happy they've bought some Hexagon software and the hardware that fits so well together. But let's keep pushing forward with the design engineering aspect to this. And I want to learn a bit more about the simulation and verification. So when you're designing, we've been talking about progressive dies today. We've done a video on progressive dies and mold, injection mold tooling, design and manufacture. But it's not just a design and then a manufacture. There is a lot of an iterative design process inside that design that needs smart simulation software. And it's normally those two would be, again, provided by separate vendors, separate software packages. And they take a long time to interface between them nicely. Whereas Visi, I mean, talking to you specifically, Marcus, Visi handles amazingly design, simulation, and a bit of CAM as well. And how important do you think simulation is with designing complex products?
It's huge. I mean, I'm going to talk Tooling 2000 again. They have their own Triac
They
presses.
love you, don't they?
They have their own Triac presses. We've got many designers across regions who are literally designing press tools, mold tools for clients. That's all they have is a computer. Even you look at CAM simulation, we all know about that. Within Visi Progress and the mold, we have a kinematic simulation, so you can actually simulate the die being closed up in a press, for instance, looking for collisions, looking for punch and die alignment. I mean, it's such a growing thing over the last decade as well, because people are thinking, well, I don't necessarily have to send those parts out for tryout. I can just get the customer to buy them off from there.
And I guess, would you say that younger engineers kind of expect that to be their bread and butter, and every piece of design software that you should and must have that? 100%. Because whereas otherwise maybe an older engineer would take one of the 2D drawings and line it up physically to go check the 2D, the alignment of the punch and the die, whereas the younger engineers would just expect all of these ease of use features to exist.
Yeah, but you also talk about, older engineers, experienced people with all these fathoms in their head about tool design. When we look at VisiBlank and Springback and mold polymer analysis within our design, it's there. Without that, you're not taking the tryout from design to tool room, back and forward. Completing different prototyping all the time. It's all in there at the design stage.
Yeah, so you spot those issues before they hit the physical aspect of and that's always the expensive bit, is the physical aspect. Yep. It's cheap to iterate in software, but I guess one of the problems is you can never be absolutely sure that your physical design is not going to have some unexpected problem. You can never eliminate the need for design engineering expertise just from experience. And can software ever, do you think, completely de-skill the process of designing a complex mold tool?
Not completely, but it can simplify it a lot. So you would have somebody in a design office. He's made a tool. He might not necessarily be that experienced on a machine center. So we have other CAD systems. One goes across all our brands, and it's called Designer, and it's more of a CAD for CAM system. So let's just say a tool designer's gone down onto the machine, and there's a rad that's not maybe machinable, for instance, because the designer have overlooked it. We've got tools at the machining stage where we're not messing with first revisions in the design office, where they can make their changes to allow them to actually manufacture the part easier.
And that's an opportunity for Dave to let's discuss. I mean, actually once the design's been approved and sent out for manufacture, there's not just an easy process you can't just put the drawing through a machine control and it makes it for you. There's a massive amount of work that goes into actually design for manufacture and manufacture itself. And that's where EdgeCam really comes into its own in a production house.
Yeah, that's right. EdgeCam's sort of mainly based on production machining. Yeah, we do a lot of stuff with the mold tool guys as well. We've got another customer there who uses their EdgeCam automation, RD Leverage.
Yes.
Yeah.
They machine all the bolster plates with EdgeCam, and it's literally 2 clicks. It's the plan, apply, the NC code's generated straight on the machine. And
so can it really be that easy though? Can the software really make those so few jobs to actually get that program out?
It can. It takes a bit of investment and perfecting the process up front. It's not going to be out of the box, but it's something we can develop along with the customer to get the most out of it and to get the software to use their methods correctly and with strategies suitable for their machines. So,
And RD Leverage is a great example for the automation inside EdgeCam, because literally within a couple of clicks, they can actually get a bolster plate milling, drilling, tapped within sort of a few clicks, and away you go on the machine. So it's the EdgeCam side of it complements the work and see, and vice versa. And it's a really nice solution to see RD Leverage leading the way in that way.
And that's, I guess, a lovely example where people can, because normally automation and high productivity you only ever see that in high volume automotive style sectors where there's a massive number of parts you need to make, so you can afford the investment into robotics, into quick change fixturing, because the parts are all the same. But I guess there's a bit of a shift towards or that kind of technology is trickling down where you can have higher mix of products that are just slightly different. You've got families of parts, but because the software is now strong enough to handle all those different families, you can actually automate that system.
No, agreed. Yeah, I mean, one of the things we do, as I say, Dave touched on it, is we work with the customer to implement the process. So it doesn't happen overnight, of course, but with the people we have around us at Hexagon who have been in the industry a long time and know how to use the software, who have been in the machine shops, who actually know how to machine the parts, they actually work with the customer to make this work.
And it's almost like you're trying to embed their knowledge into the software system.
Agreed, yeah. And this is what we do. So we speak with the customer, and we'll go on site and we'll spend time with them and actually look at the tool libraries and look at the materials that we're cutting, and actually build this process with the customer.
I remember you talking about Work NC about templates, and it almost you build up kind of a company knowledge library inside the software.
Yeah, so one of the things within Work NC, we try and capture the data or the knowledge of the people who are actually machining these parts. So, and we build in template-driven programs. So, and this we do the similar with 2.5D. As I say, we work in with RD Leverage is a great example because you're seeing EdgeCam lead the way with the automation on the 2.5D with the templates they've built, and then Work NC for the mold with the mold tools that the machining. So it's a great example to see our products in one place working in harmony. Same with Tooling 2000, same with Petford Tools. They've all got multiple solutions with ARMS and reverse engineering and software. So from Visi to Work NC to NC Simul, so it's great.
And I guess these are all really inspiring case studies and great examples, but I'm afraid it's a bit of a travesty. These are all machining examples. I'm afraid we've got a sheet metal expert standing by.
Do you know what? I'm going to happily duck out and put the expert of sheet metal.
Yeah, so we've got Liam. It's Liam Smith. There's another Smith here. So is Phil your brother, Liam?
Not quite. Yeah, sometimes I think he wishes.
Well, I'd love an accent like you, to be honest, Liam.
Liam's the better looking one.
Yeah, so it's
it's a close call. It's a close call, isn't it,
sure
Phil?
It is, yeah.
yeah, but no. So I'm an application engineer, so Phil's my boss. But from the sheet metal side of things, yeah, okay, it's not typically in that sort of milling and turning world.
No, this is totally separate to the whole design engineering simulation. Although there's a little bit of kind of the spring back simulation that I guess would apply to sheet metal work.
Yeah, and what we're seeing a lot more now is that different applications within the sheet metal world are applying to little bits of the machine, sort of milling and turning sort of world. But that's where that designer software comes in, where we can kind of like sort of crossbreed what the actual sort of softwares are doing. But what we're finding now is as parts are getting more and more complex, they're not just all sheet metal, like a traditional sheet metal shop would be, or they're not just milling and turning. So people are doing a little bit more of everything. So that's where sort of we have to sort of combine the experience.
It's definitely a bit more of a multidisciplinary approach, I guess. Engineers have to spread their knowledge and to stay competitive. Do you find that shops are taking on? Do you find that machine shops are taking on sheet metal work, or do you find that sheet metal shops are taking on machining work, and you're kind of coming in and trying to educate people on what sheet metal work really is?
Well, so yeah, what we're experiencing more and more is that the machining world are taking on a lot more of the sheet metal work. I think a lot of that's to be more of the way that it's perceived, where machinists are very sort of very, very high tolerance, and it's a case of they'll go, sheet metal, how hard can it be? So there is a case of an education is needed when we do come in and say, right, okay, we've got to understand what a bend allowance is and how that's worked out.
Yeah, surely you just plonk down a laser in one bit, a press brake, and then you're off to the races, right?
That's typically the general sort of consensus from a machining world. How hard
that shows my ignorance up. I'm sorry, thank you,
You used
Lee.
to get the Zeus book out with all the bending allowances and work all that out.
Yeah, that book isn't really around anymore.
I've got one.
Oh, there's
Show my age again.
yeah, shots fired from Lee and straight to Dave. I'm sorry, Dave. That must have hurt, man.
Nah.
No, so sheet metal is not an easy thing to do, even though some machinists like myself, as ignorant as we are, might believe it is. So you obviously represent the Radan side of things, the Radan, which is the sheet metal software, and that handles kind of design, even handles quoting. There's a big part to Radan. Let's just talk about the design engineering of sheet metal work and what Radan does to help make that easier.
So the first sort of process is, if you're looking from the CAD point of view, is where you can bring in just a standard sheet metal part, step files, SAT files, and then what you need to do is that'll come in as a typical sort of 3D model. That needs to be unfolded, so you need to understand how to develop from a 3D model into a flat blank first of all, before presenting it to the Radan software. So you've got to understand where a bend allowance is, or how much the material will stretch depending on what tooling you're using. And then once you have that flat blank, then you present it to Radan, which will then be processed through the nesting software and onto your profiler.
And I've got to say, again, as a machinist, I find some just the press brake work absolutely fascinating, and the experience that goes into picking the right tooling. So you get like kind of dogleg tooling, don't you, for undercut bends. And there's some bends that are impossible to do one way, but totally possible to do another way. They seem like, to me, kind of like a paradox.
Yeah, press braking in itself was always seen as a bit of a dark art, where you need to have someone with 10, 15 years worth of experience to understand how to sort of produce that on the press brake itself. And if you didn't have that, you end up with a lot of wastage, and that's where the software comes into its own, really.
And I see there's a common thread, whether it be machining or sheet metal, where the software is trying to, so your software packages are trying to extract some of the real nitty-gritty complexities of achieving a very specific thing that you'd have to otherwise try and employ or find a consultant who could solve that little problem for you, just to try and open up these markets to more general machine shops and more general subcontractors. Do you think that's going to make it easier to produce more difficult parts going forwards?
Well, yes is a very short answer to that, but what we really should be looking at is a case of we should, rather than making more and more complex parts, is we should be making parts that are more accessible for more things. So are you talking in terms of designing products now, in terms of the way you would design a part to be more standardized and a bit like the bolts that are being, who made the bolts on EdgeCam totally automated? The bolster plates.
Yeah.
So a bit like the bolster plates are kind of a generic part that can be automated in the way they get programmed quite easily.
Yeah, that makes pretty much.
No, that's fair enough. No, that's okay. That's a bit of a dead. That's okay. I think we've done. Are we happy with sheet metal work? Sorry, we're 21 minutes, so I'll cut to the end now. Is that okay?
Yeah.
Thank you. Brilliant. Okay, so thank you very much, sheet metal expert Liam, and Marcus has obviously gone off microphone now, but thank you everybody. Thank you Dave. Thank you Phil.
No, thank you.
It's been an absolute pleasure to find out how Hexagon are trying to not living right at the end of the production process, but bring yourselves right to the forefront of people's minds. You've been talking enough now. Thank you Dave and Phil as well, guys.
Thank you.
It's been fascinating to find out what Hexagon does for not just subcontract machine shops, but automotive and everyone in between.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.